Hello and welcome to T3 Day 16 of Honors Precalculus. Today we're going to talk about the binomial expansion theorem, but first we're going to warm up with some counting and probability problems. Suppose you are randomly dealt 5 cards from a standard deck of 52 cards, so 52 cards and it's 5 cards. What is the probability you are dealt a hand with 2 aces and 3 kings? So remember, we're trying to figure out what are the number of ways to win the game over the number of possible ways to play the game. So possible ways. So in terms of number of ways to win the game, 2 aces, there's 4 aces total, and we're choosing 2 of them. Doesn't matter which 2, so it's going to be 4 choose 2. And we're going to multiply that by, there's 4 kings, so it's going to be 4 choose 3. So it's 4 choose 2 and 4 choose 3. You multiply them together because this is the number of ways to get 2 aces, and this is the number of ways to get 3 kings, where order does not matter. And then down below is, if we have 5 cards, we're choosing 5 from a deck of 52. So 52 choose 5. So what that means is you can plug these into your calculator, and when you do that, which I highly recommend, it's a little bit faster than doing it out by hand, end up with 0.000923%. So very small chance of getting 2 aces and 3 kings if you get 5 random cards out of a standard deck of 52. So this is where we get to build a nice triangle. So what's this expansion going to look like? So we're going to expand each of them, meaning what is a plus b to the 0? Well, anything to the 0 power is 1. But if we raise this a plus b to the first power, that's just a plus b. But then if we square it, we have to be really careful. It's going to be a plus b times a plus b. You multiply it out and you get a squared plus 2ab plus b squared. You have to FOIL that out. So what you end up with is a squared plus 2ab plus b squared. Now remember, this is going to be a plus b, the next line, a plus b times a plus b times a plus b. And it gets a little tedious, and this is what it looks like when you fill the rest of this triangle in. And yes, there is a nice payoff to all of this work. Here's what you end up with if you do all that work and fill it in. So it cleans up pretty nicely, and if you arrange it like this, you can start seeing a pattern. So what you can do is write out just the coefficients. So if I write out just the numeric coefficients, you see it's 1 here, and then it was a plus b, so it's 1a plus 1b, and then it was 1, 2, 1, and then the next line was 1, 3, 3, 1, and then you fill in the rest, and you get this. It's pretty cool. This is called Pascal's Triangle. This is Pascal's Triangle, and it's pretty cool. You'll notice the pattern probably that any 2 above, 1 plus 1 is 2, 1 plus 2 is 3. This is the pattern that you can follow to fill this in. It's pretty cool. Pretty neat. So forth. So like 3 plus 1 is 4 there. So this triangle is going to be super helpful to multiply things out really quickly. So there's a nice pattern here. And just to help you see it, you can start writing these things out. Like 0 choose 0 is 1. There's one way to choose 0 things from 0. When you fill the rest of these out, you end up with the rest of Pascal's triangle here, which is pretty cool. 1, 3, 3, 1, and then you get 1, 4, 6, 4, 1. So keep in mind, this is also Pascal's triangle. These entries right here, these 3 rows are entries into Pascal's triangle, which is pretty cool. So we have both are Pascal's triangle. They're both. So what does this mean here? Well, let's say we wanted to do ab to the 6th. The way this works is you're just going to have the 6th row, the next row of Pascal's triangle. So you might think to yourself, oh gosh, I don't really want to multiply this out. A plus b, really don't want to have to multiply this out. It would take a long time. So the next thing you do is you just go to that row of Pascal's triangle. So we go back up here if you want to see it here. Here is a plus b to the 5th. To the 6th, you'd have to write out the next row. So it'd be 1, 6, 15, 20, 15, 6, 1. And that's what these coefficients are right here. So we have the coefficients we want. So what order are they in? Well, it was a to the 6th here. And then you just follow the pattern. It'll be a to the 5th b, and then it's going to be a to the 4th b squared, and then a to the 3rd b to the 3rd, and then a to the 2, b to the 4th. It always adds up to the power of 6. And this is going to be a, b to the 5th, and then b to the 6th. And it's plus in between all of these. So the powers always add up to that 6, and then you use the corresponding row of Pascal's triangle right here. In this case, it's 1, 6, 15, 20, 15, 6, and 1. The only thing you have to be careful of are the values you're plugging in for a and b. So for example, with x minus 2 to the 5th, we write out that 5th row of Pascal's triangle, so it's going to be 1, 5, 10, 10, 5, and 1. Sorry, I got to put some space in here so you can actually space it out 5 and 1, right? And then in this case, a is going to be x, and b in this case is going to be negative 2. So in this case, it's going to be x to the 5th right here, and the next term will be x to the 4th times this term to the first power, and then the next one's going to be x to the 3rd, and then it's going to be negative 2, and I'll create some more space here. Let me move this over here, so I'll move this over, create some space, so it's negative 2 to the 2nd power right here. And then it's going to be x to the 4th, negative 2, go down a power, so x to the square, negative 2 to the 3rd. And this will be 5x, and then negative 2 is to the 1st to the 4th power, and then this is going to be negative 2 to the 5th power. So whatever it is, you have to be careful. You have to be careful about it and plug it in accordingly. So in this case, you plug all those in, and you can clean it up. You definitely can clean it up, so it cleans up to this polynomial. So just be careful. You're plugging in negative 2 for b in this case. So in this case, our a value is that negative x, and our b value right there is the plus 3. So the first thing you do is you write out those coefficients. And if you don't remember what the row is, it's because it's to the 6th power, it starts with 6 choose 0. So what you can do is first it's 6 choose 0, and then it's 6 choose 1, and then it's 6 choose 2. Keep the pattern going like this, 6 choose 3. Oh, and I moved it, sorry about that. So then you get 6 choose 4, 6 choose 5, and 6 choose 6. And you can write these out first. That's what I kind of like to do. So if you write out these coefficients first, you end up with these same coefficients we had before. So 1, 6, 15, 20. The coefficients are 1, 6, 15, 20, and then it goes back down again, 15, 6, and 1. And then remember, you're going to end up with the powers being, first you have this, the first power is going to be negative x to the 6th right here. So it's going to be negative x to the 6th. And then you end up with negative x to the 5th. And then it's going to be 3 to the 1st. And then you have negative x to the 4th and 3 squared. And you fill in the rest. And you glue them all together with plus signs like this. And then yes, you can clean each of these up. You can clean each of these up. So what do you end up with when you clean this up? You end up with this, and I noticed one mistake here. This last one should be just the 3 right here to the 6th plus 729. So these are big numbers, and you'll definitely have your calculator for this. But the key thing is remembering what you're plugging in for A and for B. So you can get good at remembering what each of these rows are. So for this fourth one, remember it's going to be 4 choose 0, and then 4 choose 1. So then the A value in this case is going to be 2x, and the B value is 3. So what this looks like, if we skip right to doing it, it's going to be the first term raised to that 4th power plus the next coefficient, which is 4 choose 1, which is then going to be multiplied by 2x to the 3rd times 3 to the 1st. And then you're going to have 4 choose 2, 2x squared, 3 squared. And then you're going to have plus 4 choose 3, 2x to the 1st power. And Sadako had some feelings about that. 2x to the 1st, and then 3 to the 3rd right there. And then you're going to have the last one just be 4 choose 4, which is 1, times 3 to the 4th. And when you do this whole thing out, remember there's also an invisible, 4 choose 0 if you want to put that there. So the Pascal's triangle is, our values are here, 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 and here. And now when you clean this up, you end up with this polynomial, and this is the form I want you to end up with. Let's do one more. So here we go with another set of coefficients like we had before. And in this case, you have your A value as 2x, and then you have your B value of -1. So our first term will be 2x to the 6th power, and there's that invisible 6 choose 0 out front. And then what you're going to do is you're going to have you're going to have 6 choose 1 right there, and then it's going to be 2x to the 5th and negative 1 to the 1st, and then you're going to add to it, we'll write the whole thing up, plus 6 choose 2, continuing Pascal's triangle, and then 2x to the 4th, 1 power less than it was before, and then this one goes up, make this a little smaller because I have to write all this in, and then you have 6 choose 3, and then it's going to be 2x cubed, like this, and then you're going to have negative 1 to the 3rd power, and then you're going to have 6 choose 4, and then 2x to the 4th, and then negative 1 squared, and then you're going to have 6 choose 5, like this, 6 choose 5, and then you're going to have 2x to the 5th right here, and negative 1 to the 1st, and then you're just going to have 6 choose 6, and then have negative 1 to the 6th. And a lot of these cancel, because like negative 1 to the 6th, any even power is going to be just a regular 1, and then any negative 1 to an odd power. So for example, this is going to be a negative, this is going to be a negative, this is going to be a negative, this is going to be a negative. Excuse me, that one's not a negative, just not that one right there. So when you do this all out, clean this all up on your calculator, you end up with this. And remember those negatives right here, so that's that alternating sign that happens. Clean it up, it comes out pretty nice. So this is the final form that I want. Just be real careful. But again, here's Pascal's triangle. Here, 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 here. This, 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 and this. And again, this would be 6 choose 0, which is just 1.